a teacher here at Rainbow Middle School, and I'm here to teach you about literal equations. Literal equations are basically an equation that we're solving for a variable. Instead of a number value, which you're used to, we're solving for a letter. And usually it's because, as you can see, there's more than one variable in our equation. And we've done this before. You probably don't realize it, but we have done it before. For example, if I was solving for, say I'm finding perimeter, and we first learned how to find perimeter, which was adding all the sides. But now, as we've gotten a little bit more advanced, we add the length and the width, and we multiply times 2 to get perimeter. Well, let's say we don't know what the length is. We only know what the perimeter and the width is. So we're going to have to extrapolate a different formula so that we can solve for that. So if we look up here, here's the formula we've been using to find perimeter. Over here, we're having to do the opposite. We're having to undo it, unmake it, rearrange it so that we can use it. Here, we're having to divide by 2, so we can get rid of this 2. And then we're left with perimeter divided by 2 equals my length plus my width. And I remember I want length by itself because that's what I'm solving for. So I'm going to subtract W on both sides. And I'm left with the new formula, which is length equals perimeter divided by 2 minus the width. And that's a literal equation. We've just moved things around to solve for a particular variable. And you've seen it last year in 8th grade when we had circumference, but we didn't know a diameter. If you remember, circumference equals pi times d, right? But if we're looking for the d, I need the d to be isolated by itself. So when we're going to do that, we're going to have to get rid of this pi. And pi is multiplied by d, so we're going to divide it. So we're going to divide both sides by pi. And we get that our circumference divided by pi should give us d. And once we have that done, and that's our literal equation now, then we can solve whatever we have to do. Then we can put in the 21.98 divided by pi and get our diameter, right? Now in your Apex, they have another practical problem, and it has to do with painting a fence. Here's my fence, and it says that this side is 4 feet, and that I know that the area is 300 feet squared. The only thing I don't know is I don't know what this side is. So first thing you have to realize is that we're looking for how much something covers. So we're looking for area. Now that was pretty easy. We know that's one of the first areas we learned. So that's just area equals length times width, right? Well, I have the area, and I have one of the lengths, so I'm looking for another length, or another width. So I'm going to get rid of one of these, so I can solve for this missing side. I'm going to call that the length, so I'm going to divide by W, and then it says that my length is equal to my area divided by the width. Then I can solve that, right? Because I know the area. My area is 300 feet squared. And I know my width, that's 4. And with that, I should be able to solve for length. 300 divided by 4 would be 7 with 2 left over. And then 4 and 2 would be 5. So my length would be 75 feet, right? But sometimes we're not looking at a formula, because those are both formulas, right? Sometimes we just have an equation. For example, what if I had 10x plus 5y equals 20? And I said, I want you to solve this equation for x, okay? So that means I need x all by itself. And that's going to take some finagling. So first thing I want to do is get rid of this 5y. And 5y is just a number, right? So if it's added on this side, to undo it, I would just subtract it. But I've subtracted from both sides. That gets rid of it on this side, and I still have 10x. And then all I'm left with is the 10. I need to get rid of the 10. Now this is 10 times x. So since it's multiplied, I have to divide it. So I'm going to divide this by 10, which means I have to divide everything on this side by 10 too. So I have 10 divided by 10. Well, that's just 1x, or x. Then I have 20 divided by 10. Well, that's just 2. This is a little bit different, right? It's still a division problem, but I'm looking at this from 5 over 10, and I know that's 1/2. So I'm going to subtract 1/2 y. And there's my answer. Okay, now we're going to move on to the second unit that we have for this week, which is solving systems of equations using graphing. Okay, first, if you haven't already, I know I've said it before, but you may not have seen the post in Google Classroom. You want to download the TI emulator software for the TI-84. It's free. It's got a 90-day trial. And this is the address up here, so don't forget. It's education.ti.com/en/downloads/trial-software. And you'll be able to download the software that you're used to seeing on a calculator, okay? And this is what we're doing, this is how we're doing it on the calculator, but I'm going to show you the old-fashioned way first, all right? So I have 2 equations. This is my system. This designates the system. So I have y equals negative x plus 5, and I have y equals 2x minus 1. Well, the first thing I need to do is I need to graph these. X and my y. Okay, now if you forgot how to graphing, it's okay. It's been a while, so it's all right. First thing I have to do is I have to look for my y-intercept. My y-intercept is the plus part. This is in my y equals mx plus b, remember? This being my y-intercept, and this being my slope. Okay? So, I'm going to do this one. This one's, my y-intercept's at 5. Okay. And my slope is -1. That means for each one that I go over, I'm going down 1. Going down over 1. Going down over 1. Okay. This one, my y-intercept is -1. And this one says my slope is 2. So every one I go over, I'm going to go up 2. And draw that line. Our solution is where these 2 lines intersect. And I can see where it is. I just have to find out what that is. So that's 2. And that is 3. Now I want to make sure that's right. So I'm going to take each one of my equations and I'm going to put in the solution and make sure that it's right. So 2, 3. So here's this one. Y equals -x plus 5. My x is 2, so it's -2 plus 5. And my y is 3. So I have 3 equals -2 plus 5 is 3. And 3 does equal 3, so that's true. So that works for this one. Let's try this other one. Y equals 2x minus 1. So I'm going to substitute my 2 and my 3 in. So I have 3 equals 2 times 2 minus 1. And that's 3 equals 2 times 2 is 4. 4 minus 1 is 3. And that works. It's true also. Excuse me. Okay. So I want you to look at this particular chart. If you can take a screenshot, This is how we do it on the TI emulator. Okay. First I need to solve, I'm going to put this in my solve for y, if I need to. So if it's like 2y plus 3x, then I'm going to have to put it where it's in my y-intercept form. Y equals mx plus b. I'm going to hit the y equals key, right? Then I'm going to enter the first equation in y1, the second equation in y2. I'm going to use the graph key. That'll graph it for me. Sometimes it's, if you zoom it in, you can find out exactly where that is. Sometimes not so much. If we want to know exactly what it is, we're going to hit second calc, which is the trace button. And it's going to give us a menu that looks like this. I'm going to select 5, which says intersect. And I'm going to have to enter it about 3 times because it's going to ask me about a first curve and a second curve, and then it's going to want to know if I guess, and I don't want to guess either. On the 4th time, it's going to pop up where it says intersection at the bottom, and it's going to give you an x value and a y value. And if you look here, this is the one we just worked, and it says my solution should be x is 2 and y is 3. And that's correct. That's what we just did, right? So it works. But you know, sometimes it doesn't always work out like that. And there's no equation. We just did, right? Sometimes it looks like this. So if my solution is where these 2 lines intersect, these lines are never going to intersect. These are parallel. That means there's absolutely no solution, okay? Both of these equations wound up being on the same line. And if that's true, that means every part or every point on that line is an intersection. So that means it's going to have infinitely many solutions, okay? You just got to be really careful when we look through this. And this is going to happen also when we do substitution. So let's work another one. Say I have y equals negative x minus 4. And then we have y equals negative 1/2 times 2x plus 8, right? So I'm going to have to do a little working on this one, right? Because this one isn't in y equals mx plus b. So let's see. Y equals negative 1/2 times 2 would be what? Negative 1x. And negative 1/2 times 8 would be minus 4. So that would wind up being y equals negative x minus 4. Uh-oh. I just noticed that this now is exactly the same as the first one. So what would that look like here? That would be the exact same line, right? It would look like this. And if you want to be sure, it's okay. Put it in your calculator. Put them in there. You can put them in just like this if you want to. You don't have to do this first. Just put them in there. And it should come up just like this that shows you have infinitely many solutions because they lap on top of each other, right? And then sometimes you have something that looks like this. Actually, I think that's going to do the same thing, isn't it? Because look at this one. 2 times x is 2x, and 2 times negative 2 is negative 4. That one has infinitely many solutions too. Okay. Now, in Apex, it's going to show you a couple more. One is you're going to have to write equations for the lines you see. So if you're going to have to write an equation for the graph that you see, you're going to have to work backwards the way we did a while ago. So you have to find your y-intercept first, and then figure out what your slope is. You remember how to do that. We did that last year in 8th grade, right? Sometimes the ones I am going to show you that you do in Apex are tables. And that's because we haven't done tables in a little while. Let's see, I have negative 1 and 6, 0 and 5, 1 and 4, 2 and 3, 3 and 2, negative 1, negative 3, 0, negative 1, 1, 1, 2 and 3, and 3 and 5. Okay, so now instead of a graph, it's giving me a couple of tables. So first thing we're going to do is identify the x or the y-intercept like we did on the graph. Well, we know what's the value of x at the y-intercept. It's 0, right? So if I look at the table, I'm looking for where x equals 0, and that's my y-intercept. So this one's going to be a plus 5, right? And that's where x is 0. This one is going to be a negative 1. Now I just need to find my slope, right? So let's look at the slope here. Remember, I'm looking for the change in x, or the change in y, over the change in x. So how is my y changing? Each time it looks like it's going down 1, right? That's a negative 1. What about this one? Well, this one, it looks like it's going up 1 each time. So negative 1 over 1 is negative 1x. So that is negative x plus 5 is this equation for this one. On this one, let's look at this one. Negative 3 to negative 1 is 2. Negative 1 to 1 is 2. So it's looking good. It's still 2. This one, it looks like it's going up, what, by 1 each time? So this is 2 over 1, which is 2. So this, my equation is y equals 2x minus 1. So now that we got these, then we just have to put it into our calculator and find our point of intersection, or we can do it the old-fashioned way, either way. And your point of intersection will be your solution. Or you could have no solution, or you could have infinitely many solutions. And that's it.